Then you add the back. So they are ordered, so normally they should be okay.
Okay.
Yes, and now we are on time. So. Yeah, we can start.
All right, it's time. If you want to make yourself comfortable in a seat, all right, so this is the ops area meeting. We are meeting after a fairly long time, at least the first time that both Med and I have been ops areas. So we will quickly get through the set of slides. So here's, of course, the note well that you all are familiar with. If you're not, do follow the links at the bottom of the slide for any for you to get familiar with the note well requirements. What we are missing is the note well slide, uh, but the whole idea of the note well slide is for you to be that we are here participating, and we want to respect the participation of all the people in IETF. So do that in a respectable fashion. So we have a fairly packed agenda, and we'll try to stick to the timing as much as possible. So presenters would request you to keep to that time slot. Here's the agenda for today. Any questions about the agenda or any bashing of the agenda? All right. If not, let's jump into the state of the OPSAREA.
Close the microphone, okay, or come to front?
There'll be a quick switch up in the front.
A mass running exercise.
Oh, sorry, maybe I need to pass.
It's okay.
Sorry, I'm out of time.
Nice. should work anyway for this.
No? Okay.
Yeah.
Okay, yeah, so ANIMA, Autonomic Networking Integrated Model and Approach. Objective, we're have so far and still are building software infrastructure, forwarding control plane for networks to be secure, autonomically running. So whether you're running them from SDN controllers manually or whether you are running distributed automation, which we are calling ANIs, ASA, and that is one of the things we're trying to look into now. The three terms for the ANI: secure bootstrap, automatic secure IPv6 connectivity, and generic signaling. Current hot topics. We have a variation of the bootstrap protocol Brewski that we're going through just to create another fine cluster for the RFC editor. And we've started to offload into it, and it will finish up with RFC 8366 bis. Then discovery in the network with various protocols for this bootstrap. We have hackathon POC implementations for these components going on. And we also had an interim working towards various use cases that hopefully can translate into drafts for autonomic service agents for decentralized automation. So main achievements, primarily adoption of 3 new working group drafts and no charter changes since 1.2.2.
Thank you. We'll suggest the next remaining presenters just stick to the hot topics because we may run out of time. So who is here to present? Actually,
You can just keep it in the mic.
Yeah, hello, this is an update about benchmarking methodology working group. So What are the main objectives? So this group is tasked to define recommendations concerning the key performance characteristics of network device systems and service. In particular, the set of benchmarking defined here are of interest for users and those affected by benchmarks, so vendors, equipment manufacturers in general. It's important that this characterization is done under controlled stimuli in a lab environment, so it's not operational networks. Current hot topics are related to revisiting BMW GRFCs in order to update the old RFC 2544 and the definition of benchmarking methodology for new technologies that usually are defined in other related working groups like Spring, SaveNet, CATS, and so on. Main achievements, we have a draft submitted to SG for publication, other draft in preparation for working group last call, and candidate for adoption. Mainly the ML research has been just submitted to SG. No charter and no leadership update since last IETF.
Thank you.
You can just use the mic directly below there.
No, that's okay. Because we can't read
excellent.
it.
Oh. So DNSOP. I skipped the main objectives. DNSOP is the kind of DNS catch-all working group, but it's not in the other. Right. I'll take the mic. Yeah, there we go. The DNSOP is the DNS catch-all working group. So it's not appropriate draft for other DNS working groups. It's up at DNSOP. The current hot topics, main issues we work on, and it's quite recently more and more drafts we see, and I call it the DNS versus application interaction draft. Put 3 examples: domain verification, think of the ACME protocol, for example, structured DNS errors, there are all kinds of DNS errors, and well, the operator knows if there's an error, how to handle, but you want to communicate the error also to the end user, the person like me behind the web page or web browser, what's going on, is it filtered because of, etc. So, and recently also DNS name integration into web frameworks, application frameworks. It's an interesting topic. Active drafts focusing on DNSSEC automation deployment. Is DNSSEC not already done? Yes, it's done. It's a success. It's a success. Pun intended here. But we can do better. So there's a lot of drafts still working on DNSSEC deployment and make the ease of deployment and necessary protocols that not necessarily are DNSSEC related, but okay, I will skip. And well, the regular maintenance and ops drafts maintenance work. I want to mention we have a new chair, Andre. Thank you, very happy, and Secretary Peter Thomason and Schumann Huck. Thanks.
Thank you.
Green networking group. So we're doing stuff related to energy statistics, reporting those off the devices, and also some level of control. It's a relatively new working group, so we're also getting going. Key aims now is to adopt a couple of documents. We're getting close to doing those. Otherwise, there's some work on data models, and we'll have some interims, lightweight interims design team meetings going forward over the next few months. So it's just progressing. That's it. Thanks.
Thank you.
Who is going to present from Grow?
Do you have which one? There's one slide, I think there's IoT Ops before, no?
No,
No,
it come after.
Green and Grow. Oh, there is there. No, the previous one. Yes, yes, it's surprised.
Hello. I just entered the room. This is Job's slides, so I don't even know what we have here. But yeah, Grow working group. Next slide, I guess.
That's it.
No, that's
Only
it.
Yes. Fantastic. So yeah, the Grow working group would be, like IDR, they define BGP. We have, routing and BGP operations in Grow. recent thing that happened, I mean, we had a leadership change. I became co-chair together with Job. We have a new secretary. Lots of work going on the BMP protocol. That is taking more or less half of the bandwidth of the group, and let's say we really increased our bandwidth from 1 hour not fully packed a couple of years ago to full 2 hours right now.
Thank
so
you.
Lots of stuff going on.
Thank you, Paolo. Thank you, Paolo. Yeah.
Hi. IoT Ops is Internet of Things operations. We kind of have two goals. One is people can bring topics and raise awareness about IoT-related things inside and outside of IETF. We also have a little bit of dispatch type function. So, but we recently got rechartered to allow working on proposed standards for MUD-related stuff. Hot topics, yeah, we adopted several documents. We had today presentation about how to do inventory of devices on local network, IoT devices on local networks, as well as DNS-related considerations for running IoT devices.
Thank you, Alexis. Thomas?
Yes, so that would be the IP performance measurement working group, and our main objectives are STAMP and hybrid ORM maintenance extensions. And we also do end user centric measurements and benchmarking. And currently the hot topics are, we have many IOM related proposed works and lightning talks. So there seems to be a lot of interest in that area. And like we have currently two documented ISGs, the capacity protocol and encrypted PDMV2, which are both sharing a bit security related challenges. So there's a lot of back and forward. And the last one is, terminology is always something like everybody has an opinion on. So here in this particular point is basically we evolved from radio to IP, so it's no longer about in-band and out-band, and there are different terms, and also it's a collaboration between OPSAREA WG and IPPM. Yeah, that's it. Thanks.
Thank you, Thomas.
Ivy, despite the name, we don't work on plans, we work on inventory. We had 6 items in our charter, and we have 6 documents. So surprisingly, everything is going well. We are working on delivering as fast as possible a base core model for inventory. The more we work, the more anger we get. So we wanted to add, but it's time to draw a line, ship the document to the SG for publication, and then maybe add on top of that. We are working on inventory location, mapping to other IETF models, topology and stuff like that, software, and we recently added the passive inventory, and we are working on adding entitlements and licenses.
Danny?
MBOND working group. Our focus is on all exploring and documenting all areas of operations and deployment issues related to multicast. We develop tools and sometimes protocols that are related to operations and troubleshooting and administration of networking. And what we're working on most now is addressing gaps related to transport layer and security issues that may be impeding multicast deployment on networks. The latest, kind of most interesting drafts we're working on, documents we're working on right now are several drafts that are related to making multicast safe for the browser, so that we can get multicast running in browsers. Recent recharter, and Yeah, that's it.
Thank you, Lenny.
Media operations, we were largely chartered to provide a venue for cross connections between disparate groups working on IP related delivery of video or video delivered via IP, depending on which industry you come from. So we've provided a bit of an industry entry point, if you will, for video. So we are not particularly focused on creating documents or creating standards. We are in fact chartered not to create standards. We have published a few RFCs, informational, either about video and internet technology or some specific individual contributions that we help shepherd with some input from broader industry eyes. We are currently working on the impacts of network overlays on streaming video. So that's a current working group document, and it is pretty much the hot topic. Yep, and otherwise we're pretty boring. No charter update and no leadership update. Thank you.
Thank you, Leslie.
Okay, so NetConf, hot topics, various notification documents. Yang Push Lite is ongoing. NetConf over quick, I'd say, or we think is the hot topics right now. Main achievements since last IETF, a lot of documents actually in post-working group status have managed to gather more and encourage more participation within the working group through shepherding, etc. No charter update, but we have a new working group secretary. Thanks.
Thank you. NetMod?
Hi, I'm not sure if Lou made it to the room or not, but network modeling. Current hot topics include module versioning and server support for multiple versions, configuration templates, and of course, hopefully a new version of Yang will start getting worked on in sometime future.
All right, for Nmap, what we have, the first item is the Yang push integration message broker. So on this one, we have hackathon work. It will be presented again in more extended lengths tomorrow. We have 2 sessions Nmap, and now it's not enough to present all the hackathon stuff we do. The second topic is network anomaly detection architecture. And again, there is like hackathon work being happening. On the CMAP, which was called initially Digital Map, there is again the hackathon that shows the challenges and brings proposal on how to address this. And there will be a link with Ivy, by the way. In the hot topic, there is the update of the RFC 3545. So it comes from the NEMOPS working group. So we clarify in the working group why we need this document, and it's most likely going to be accepted as a working document. And the last hot topic is that there is like a work going on, at least a design team on knowledge graph, with the idea to try to understand whether there is something to be done in the IETF about knowledge graph.
Thank you.
And that's about it.
Yes, Joe.
Ops AWG, we do everything. We used to. We rechartered. Come see us next after this meeting, and we'll talk about, we have milestones now. Recently, and operators are loving this, we have gotten TACX over TLS pushed to the ISG. We're also working on some IP fix documents and the data manifest for contextualized telemetry data. Hot topics, Thomas alluded to the guidelines for characterizing OAM with IPPM's help. We're also trying to get PCAP as historic and PCAP NG published. We did get some RFCs put through since 122. And as IoT Ops mentioned, we pushed some MUD info over there. So that's about it. Come join us. We're next.
Luigi?
CyberOps, so everything that is around secure interdomain routing, especially RPKI. Main topics is version 2 of the protocol that connects RPKI and the routers. Working also on the so-called ASPA, so which is Autonomous System Provider Authorization, so go beyond the ROA certification. We were a bit stuck on this version 2 protocol for RPKI, but I hope we are unstuck now. We are progressing well. No charter changes, new co-chair, that would be me, Luigi, and 2 new technical advisors, so Kayur and Chris.
And I'll be talking about SRv6 Ops. We are a fairly new working group. We are a forum for talking about operations of SRv6 and documenting some of the operational and deployment considerations. This time we had 3 amazing talks. That's from a service provider, an internet exchange, and a web service company, all using SRv6, and what are the issues that they are facing, and some suggestions for us to further work on. We are thinking of adopting a couple of documents, the deployment options and the problem summary draft, which might be coming in between the IETF. We have been successful in bringing new operators in who have otherwise not participated, so that's been good. We also created a website mainly focusing on them instead of pointing to data tracker, which can be a little bit scary places for some folks. Coming up with a working group external facing only for operators. So if people have suggestions on that, people who are doing ops things in the past, come and reach out and share that with us. Thanks.
Nick?
I'll hurry because I'm last. So this is the IPv6 Operations Working Group. Our goal is to identify and resolve deployment and operations issues pertaining to IPv6. A lot of what we've been working on now, as you can see, is IPv6 only and IPv6 transition to IPv6 only, like IPv6 mostly. You can look in our current hot topics, they'll define all that, and we're looking to help better clarify on IPv6 only and further allow for better definitions for prefix discovery and a AAA or Quad A filtering. Main achievements since IETF 122, we published an ND considerations draft that's in the RFC editor's queue. We've pushed CE routers and LAN DHCPv6 prefix delegations in Auth 48, and we have Prefer 8781 that is submitted to IESG for publication. Got no charter updates, and we're currently working with ADs on some potential leadership updates.
Thank you, Nick. Reza? 1 minute, please.
During the IETF, there was lots of discussion about application of AI, generative AI, various aspects of agentic AI. What we are proposing here, how we can use all those in the context of a network operation. So AI net for operations. This is a work that we have started with a few operators and vendors. There is a draft here. This is really related to the application of various aspects of the AI, generative AI, the agentic AI in the context of operation, in the area of the full life cycle of operation, from planning, assurance, automation, configuration, telemetry collection, and so forth. I'm encouraging you to take a look at the draft that we have here. There is a mailing list. We're also active on the agent-to-agent mailing list. This is a good activity. We are encouraging people to come and talk to us if there is anything we can do together. Thank you.
Thank you. Ines?
Hi, about SETL, Secure Access to TLS Local Resources, is a proposed working group, which a problem overview is basically that many local servers, like printers, they still rely on encrypted and authenticated connections, creating security risk and poor user experience. So SETL aims to address these problems from an operational point of view, with the main objective of define the problems and the requirements. So we have yesterday a site meeting, and the next step is to address the action points from the site meetings, basically working the charter. Thank you.
Thank you, Ines. Joe or Drew?
Onions. It's about layers. Get it? This is our target here is a working group. We are currently in the chartering phase. We had a side meeting here. It's about operationalizing network and service abstractions, but really it is about layers. The idea here is Based on some of the feedback from NEMOPS, and based on the work that's already happened around service and network layer level modules and models in the IETF, we want to consolidate that, bring together these abstracted layered modules and models, and create APIs on top of them to help people better adopt and operationalize and realize how they can build these network holistic services. As I mentioned, Dhruv and I are working on the charter right now. We hope to have that text stable in the near future, at which point we will start formal work group chartering. You can see the text there in GitHub. We do have a non-working group mailing list already, onions@ietf.org. So we encourage you to join and participate in the discussion if you're interested. Thank you.
Jeff?
The DNS Directorate, a well-oiled machine, predominantly because I think the Directorate members are actually really very, very good at the job, and my thanks to them, and Jim's as well. The aim is to review most of the IDs with DNS content. It's really up to the folk who refer it to us. Some of the reviews are minimal because it's easy, some get incredibly detailed. It helps the authors and helps the working group if you get reviews early in the life cycle rather than at the last minute. So get in early. No issues, no hot topics as this particular juncture. We get little feedback. It's basically integrated advice that seems to work. No changes since the last IETF meeting. We've processed 15 documents and the other 48 had absolutely no DNS protein whatsoever. So we discarded them out of hand. Thank you.
So the Performance Metrics Directorate, obviously we care about performance metrics, so we are supporting our ops area directors, but also we give guidance to the performance metrics and protocol development. Currently, me and Marcus took over the chairing from the late Al Morton. So first we re-established contacts to our reviewers. So many thanks here to Amr, to Benoit, to Carlos, Giuseppe, Paul, and Jin, who are reviewing documents. We completed the first review since we are re-established. We are looking for more reviewers. So please, if you are interested in performance metrics, reach out to us. We like to have more reviewers. Thanks.
Thank you, Thomas.
This is OPSAREA. Similar as Performance DNS directory, Ops directory, we also conduct last call and early reviews. Well, our goal is different because we try to raise awareness on the ops, like operation and management consideration, and we hope there is a dedicated section on operation and management on that. And on the admission changes, we now have new chair coming. Welcome, Daniele. And now we have 40 members. If you are interested in OPSAREA, we will still welcome because we have you can see that since last IETF meeting, we received 64 reviews, but we completed 52. Now we are working, keeps working on improve the completion and the efficiency. Thanks.
Thank you.
Yes, so Yang doctors, we review all Yang models going into the ISG for the ops ADs. Current hot topics, not much. The Yang doctors, the experts know what to do. Maybe RFC 8407 BIS might be a thing. It's hot. Main achievements, we have 56 completed reviews, no charter update. We have total, I would say, leadership update. So two new, it says chairs, but secretaries, myself and Shifang Ma. And if it doesn't say so here, but if you know Yang and would like to participate and help in reviewing those Yang modules, please reach out because we're currently, I think, 11 or so Yang doctors, and we're maintaining the load, but it would be nice to be a few more. Thank you.
Thank you, Per.
All right, so I want to present, I guess you know about this RFC 5706, which is about guidelines for considering operation and management in IETF specification. That's the one which is used by the Ops Directorate. Now, this RFC was published like 15 years ago. The content is a bit old. It still speaks about you should be doing a MIP module. So I think it needs a refresh. The audiences document is actually too many audiences. It goes from protocol designer, it goes to the ops reviewers, a little bit of the AD, etc. So we need a better scope for this. The guidance is also lost because we tried to do at that time also a list of the different data modelings and different protocols. So what we need to have is to help the people writing operational consideration section to guide them on what they need to have in there, to identify the key consideration they need to address. The challenge is always to find the right balance here. So the Ops Directorate, as we've been observing, is doing good job, but sometimes it arrives too late. It's almost at the table of the ISG, and some people say, yes, but my document is kind of old. I just want to get it done, and I will not going to change everything for operation and management consideration, while actually this should have been addressed earlier in the process. Now, the guidance to the Ops Directorate is not lost. We're going to have it on the wiki somewhere as organized by the AD. So we had an aggressive plan by Med. So he said, April 7th, we start. So sorry, week of April 7th, you submit the first document. The discussion will happen on the OPSWG mailing list, but also Ops Directorate. And he said, I will be sponsoring this document. Why? Because this document is actually addressing all of us in the room. But the Ops area is not a working group. There is no way we could adopt a document in the Ops area directly. As a consequence, it's adopted. Early on, Matt started to get feedback cross area about getting this job done. And I'm going to express what it means. He gave us a list of things to look at, information model, guidance on data models, soft on the mid part, obviously, more on Yang, etc., etc. He said, you present in the IETF 1, 2, 3, and I'm here. And Joe Clark presented this in the routing area. I'll give feedback. And the aggressive plan says by October, last call. Now, we're not used to that speed in the IETF, but guess what? We're on track. So since April, we went through 3 revisions of the draft. And why are we on track? Because the authors from the design team set up by Matt, we meet every week, and we work directly from the markdown, and we just get the PR adopted and directly in the call. So this is refreshing to me. I like this way of working, and we're on track. What else? Alvaro is a document shepherd, and somehow we're happy about that because he comes from routing, and routing might be the first customer of this work, right? So somehow he brings this perspective there. And we receive a lot of feedback from Alvaro, which we're discussing, and from Shangfeng, and we need to address it also. So where is this heading to? Well, the point is that we should have an operational and management consideration section in the draft. That would help. That would help to think about operation first. Now, there is a discussion on how to get the title right, and I'll cover that. But it's a requirement for a new section in all draft. In the end, I mean, it's obvious that we've got a security consideration section in all drafts. It's time to make this operationally as well. Now, the approach. I don't plan to read everything here, read the draft, but a couple of points I want to make is that We don't mandate that you're going to do the full FCAPs and everything, a full comprehensive inventory. The key point is that we must be explaining how to ease deployability, because if you have a protocol extension, and you don't explain to operators how they need to get it operated, it's not helping. We don't want to impose a solution. In the end, we want just you to think early on like how you should do it. And we all agree that depending on the area, it's going to be different. If I speak about applications, the way to manage application is different than managing routing protocol. Tools. We don't develop tools at the IETF, but we want you to think about how the tool would be used. And I think the key message, the last bullet point, is that we ideally want you to think about the ops things early on. And as opposed to just say, oh, you know, get it after. When I was ops AD and I had like reviews from routing, would say, you know, it's too late. You come with the discuss, but actually we'll do that later. You know, this later, the phase 2, 3, 4, 5. So that's basically the key message. Open issues. Alvaro mentioned that there is some scope creep. So, and somehow we need to refocus this document. We did already a little bit, but really to the people writing the operational consideration section. And we have some proposal there. On the what's the right title, right, bullet number 2. We are ops. We know that we've got like someone in operation and someone in management, which is exactly right. But if you come from outside of ops, do we care? Do we want to be perfect? Should the security consideration, to make an analogy, be called like authentication, encryption, data integrity, you name it? No. I mean, it's just a placeholder, but we know that in there we will have 2 types of advice or guidance. And Chongfeng mentioned rightly that, again, today the draft is too long. We try to reduce it. We must go to the point to say, these are the instructions on how to write those considerations. So still work in progress. Sorry. This one, I want to get feedback on, ideally at the end of the discussion. What do you want to target? All document type, which is like standard track, plus informational, plus experimental, or we just focus this on expert or standard track only? So Alvaro is a proponent to say it should be in all drafts. So think about that to come to the mic at the end of the presentation, which is pretty soon. Joe Clark presented, is also a member here, presented the routing area. So as AD, Jim said, you know, if we arrive with the ops directorate or ops consideration at the time of the ISG, it's like too late. We should do it earlier. John, I try to quote you. If it's not right, you correct this, please. He said, such mandatory action will lead people to decide when to start looking at the work. And he said also, it's mainly useful if you think about this section early on. So it's actually a group effort by the doc shepherd, by the working group, by the chair, to start thinking about those points early on. And if there is nothing, we're not going to imposing that you need to have a text like this, right? And Ketan had a good point, and we didn't thought about that, is that in routing, for example, there are routing protocols. There were no operational consideration for some of them. Now we do an extension. Shall we do an operational consideration section just in the extension, or should we revisit the operational aspect of the base protocol? And the last slide, because I want to have time for discussion, is the contribution is out there. Everything is like GitHub open issues. The discussion is in the ops mailing list. And I'm thinking for a couple of years, I mean, I'll put it a different way. I have the chance to see you all here. And the OPSAREA was not happening for many, many years. So I'm thinking, what if all of us would start already by having operational consideration in our draft, right? Because somehow we have to lead by example, and we know about ops, right? So then we could be asking the other area to do this. And I start to see some examples already with this operational consideration section. So I was quick because I wanted to get feedback on this document. Feel free.
Any comments, Rob? No, sorry, John.
Yeah, two things. One is you asked for feedback about, standards track versus et cetera, et cetera. My feedback is, at least coming out of the routing area, we've seen, I don't know if it's an increase or anyway, a continuation of the practice of using experimental to publish things that might otherwise be standards track. So I don't think that, I think that at least things in that category, like protocol documents that are protocol documents, but they're not on the standards track, are probably still worth putting this section into. So I don't know if that means you should say it just goes in everything, or if it means you should say, you're all grown-ups, please use your discretion. But one way or another, I think protocol documents should have this section. And I had a second thing, but I forgot what it was, so I'll sit down.
Can
and
I
let
just
someone
want
talk.
on this one, you'll give you time to think about a second point. So in the experimental RFCs, when I was AD, I was always putting a discuss, or whenever I didn't have the section, which is how do you consider the experiment successful, right? And this may be part where we could have it in there. So if it's in there, maybe you don't need it as a section, but I like what you said, that maybe let's make it for all the documents.
Yeah, I don't want to take the bait to go off on talking about what the appropriate use of experimental is, but I know it's a discussion. I remember what my other thing is. What you quoted Ketan a few slides back, and I actually took something a little bit different from what he said, and I'm not sure if he's in the room to speak for himself, but what I got from that was. For some groups might wish to write a omnibus base protocol or management considerations document for protocol, which then would be on the one hand a large piece of work, on the other hand it would be something that further extensions would have the opportunity to just say, please see RFC blah. If you think that's a reasonable approach, I think that would be sort of an interesting negotiation to have with some of the other working groups.
Thank you. Ketan, anything to add to this, or we're good? Sorry if I change a queue,
No,
but...
he's there in the queue.
Oh, okay.
Go ahead, Rob.
I was going to say, I would definitely mandate for standards track documents and leave it more optional for the others. I do agree with John's point, though. If you're doing any sort of protocol, it makes sense to have this consideration. So it needs to be thought about, at least in those docs.
Tolles Eckert. So I'm thinking of something where we do have a protocol group and ops group for that, right? So if I phrase it a really bad joke, are you going to pay unemployment insurance for the MBOND chairs when we put all the operational considerations into the PIM specs, right? So, I mean, I'm all for this, right? So great. I'll need to read through all the details and figure out what to make of it. But it's kind of, when we already have protocol and ops, or for example, in Anima, it's an ops working group, but we specify protocols. And then there are these, oh, I remember that particular area director that says 125 pages already long, put your operational considerations in a separate document, right? So, I mean, I think there are all type of cases, and we'll just need to experiment with it more. Maybe that may not be good for you because it may mean we'll take back experience from experimenting with the content of this before we finish this and take that into account.
That's a good thing, like SRv6 ops versus the... Okay, good point.
Okay. Ketan Talalikar as a routing AD. I do support for various types of tracks of documents, not necessarily only standards track. And the second thing is I invite the ops community to contribute or put together things, the base documents that John just referenced for routing protocols. And if you, for anything, feel free to reach out to the routing ADs and the ops ADs. I'm kind of volunteering us if you need any help in doing so. So again, I invite the ops community to help put those base documents forward. So then it becomes a little more practical and helpful thing to do this incremental updates.
Thank you.
Thank you.
Thank you, Benoit. Michel?
Hi, everyone. Today I'm going to present a network feature, a host feature we deploy at Google, which we find it pretty useful in improving users' network availability. Just a little bit about myself. I'm Yu-Chong Chen. I work more in the transport and the congestion control area. Did a lot of on Linux TCP and BBR congestion control. So I'm happy to be here for the first time in OPSAREA to meet all the ops people. So what am I trying to get about this PRR thing? We call it protective reroute. Essentially, it's a way to have the flow select different paths when it encounters some problems. And we have deployed this feature. This is implemented on the host. We deployed that in Google over 6 years, and it has been quite successful in terms of improving the reliability from the customer applications perspective. So I'm here to kind of promote this feature and would like to interact with you all to kind of learn what your feedback would be. Okay, so let's start with network availability. Pretty simple. The time you take between the failure, the faster you can repair, the better availability the user experiences. And that's really what we are focusing on today, is that when the network has some failures underneath, how fast can we recover from the application's perspective? So we have been doing this for routing, right? Routing has backup paths when a hub has failed. We have backup paths. We have the fast reroute feature that trying to kind of move traffic quickly to the backup paths. But what we have learned from our Google Network Ops people is that as the network continue to scale, these repairs become sometimes much longer, or it's getting harder and harder to kind of trying to repair everything within sort of, say, minutes or seconds that customer don't feel anything, right? Because that's really what we are looking for, is that the minimum disruption to the customers. And maybe the network repair can be undergoing, but we're really trying to say, how do we let the bits continue to flow as much as possible? And what we look into is essentially the multi-path opportunity in the Google network is that for any A to B, you have a lot of paths generally. And if you have a lot of paths and you assume that they don't fail at the same time, you really just trying to kind of quickly repass to a working one. And how do we do that if we are allowed to change the end host? Because in Google Network, we also control the Google end host stacks. And if you kind of think about applications have been doing this for years, decades, right? They have one connection, and sometimes they have multiple connections. And I just take all these different paths. And when they encounter problems on one connection, they either just try on a different connection, or they open a new connection and try it. And a lot of time, things will continue to work. And many applications have done that. Browser does that, do that all the time. So what we are trying to do is, well, what if we just ask Google application to do all this? Well, that's a big effort because we have many applications. Or you have to pay a lot of more cores and memories because they are going to think about this. Every Google flow now want to have sort of 4 or 10 times more connections for redundancy. So essentially, we start looking at, well, what if we just change the TCP flow itself and leverage the IPv6 flow label, because internally we have all moved to IPv6. So what you can do is, if you are changing the flow label and the routers in between on the ECMP will hash this IPv6 flow label in addition to the 4 tuples, then every time you change the flow label, it will flow to a different, take a different path. And you can just do this. And what here I want to clarify is that I'm not trying to change the flow label of every single packet on the TCP flow, because that's basically gonna spray the TCP like hell and you will cause a lot of reorderings. What we are trying to do here is that we only do this when TCP encounter certain events that indicate that the progress is stalling. And the most obvious one is the TCP timeout, which will cover the forward pass, but you can do that. What if the reverse pass is actually the one that's broken? Then you kind of rely on the receiver receiving duplicate data like retransmissions to say, oh, look like the ACK has some problem getting through, so let me change the flow label on the ACK pass. But basically for that same TCP flow, there is really only 2 active paths going on, then using 2 different flow labels. We're not trying to use multiple flow labels. And this change is actually incredibly easy to implement in TCP. Honestly, it's literally 1 line in the TCP Linux kernel. And we can do this for other transport, because a lot of other transport have some notion of on timeout, let me do something like send a probe packet, or have some way to deal with duplicate data. So we were able to kind of deploy this to avoid this kind of black hole by essentially let's say you start with the red flow, a black hole started, then TCP times out, then you try the green pass. Sometimes the green pass may not work. You hit the same black hole, but then guess what? You just do the exponential backoff and retry until you either find the new pass or the application gets too impatient and times out and kind of destroy the connection. Most of the time, we find out the application was able to continue without really getting a disruption, like a RPC layer timeout. So that's pretty much the idea. And the nice thing about this, if you think about that, is, let me go back to this picture, is you don't need to wait for all the router to support this feature. Wherever you deploy this feature, you get better availability there. So you can incrementally deploy that, right? And I know like a lot of network like ours have multiple vendor devices. So we just trying to upgrade them one by one. And that's pretty compatible. And some of the router may have some local sort of low balancing, port switching kind of like ability. This is all compatible, because what the transport layer trying to do is simply, if my progress is stalling, I will trying to repass and see. So this is based on a real experiment we have been doing. So during, so B4 is our Google wide area backbone, and we have been sending this essentially UDP like a ping probes, right? And during an outage, you can see that the probe rate between 2 metros just shoots straight up. And then after some repairs start kicking in and some congestion being managed, the loss rate drops halfway, but still high, until the outage is completely repaired in about 14 minutes. And in the meantime, we also send this TCP probe, but we have not enabled this PRR feature yet. And you can see like our TCP user probes also shoot straight up, and then they time out, so they reconnect, which essentially is trying a different path. So you see that the loss rate quickly drops down to very, very low and remains that way. And the next one we compare is TCP now with this flow label changing feature. And you'll see that it's basically just lie at the horizontal flat line, that it never has any disruptions, because it just RTO fire after a few RTTs later finds a repass. If not, maybe try again 1, 3, 2 times, and it worked. So from applications point of view is that nothing happened. It just keeps flowing. And if you actually even zoom into this a little bit further, you can see it's actually not a complete flat line. Yes, even with PRR, initially, as I said, it's not like you randomize the flow label and then you will always find a working path. Sometimes it takes a few times to try. And some of them, because they are just too unlucky, you do hit this tail that they never find a new working path, and eventually times out after, say, 3 seconds, which is our proper timeout. But generally, most of the connections probes never experience any disruption. So to talk about the sort of our deployment experience, is that this feature is almost like free. It's 1 line change on the sender side, 4 line change on the receiver side. There's really no CPU or memory cost on sort of the end host. And our routers, once we get our vendors to support this feature, you just add it in. And it's very, very incrementally deployable. You can just support certain devices and it will work. And in fact, Linux has implemented this as a default feature. And overall, our experience was quite good. Like, we really have seen quite a massive reduction in terms of like outage minutes after this feature rolls out. So with that, I'm just gonna conclude here and take questions if there is any. Oh, actually, I have one more slide, but basically, like, we think the V6 flow label is quite useful. And one thing I do want to mention is that, yes, we have the advantage of we control the servers. And sometimes a lot of ops folks probably don't have that luxury. But there are other ways to do this. For example, for our Google Cloud, we don't really control what people run their VMs. This could be multiple different kind of network stack. So what we do in Google Cloud is that in our cloud hypervisor, we kind of implement similar facility. You do have to monitor this network and trying to change the flow labels of the tunnel, but it works just same way fundamentally. And it's more evolved effort to develop this software feature. But once you have that, then you can protect, like, say, cloud clients as well. All right, that's it.
Yep. Pascal?
Pascal Hubert, no affiliation. Well, thank you for this. It's a nice demonstration. There are some hidden assumptions that make it work very well for you. For instance, you have FAT3, so you have this large amount of SCMP, which is not necessarily available end-to-end between other devices. And you know how the hash is being done. So when you rehash, when you recompute the flow label, you have a good chance to fall outside for a different hash, which will be routed differently. But if the host doesn't have a clue about how the hash is done and how many hash possibilities there are, it might be that it falls into the same bucket as before. So the more buckets you have and the more knowledge you have about the way the hashing is done, then the best chance you have to find a different path. So when you have a closed environment like this, it's very easy. If you have only 2-3 paths, and you just rehash like this without knowledge of the hash function, you might fall in the same path again.
Okay, I just want to clarify that the host actually have no idea about how a particular flow label value would do to the path. It just completely sends a
okay, so you have a large ECMP range, and the hash has a good chance to fall somewhere else.
That's right. Like, you do need to have pretty good entropy in terms of this hash, the path.
You result in 2, 3, 4 values. Sorry.
Thomas?
Yes, but the random will fall into 1 out of X. Yeah, so it just depends on how many X there are.
So just one clarification, if I understood correctly. So the goal here is actually to prevent that the transport session is being re-established during an outage. Because when packets of that transport sessions are timing out, you assume that there are failing ECMP passes, and with the flow label changes, you're trying to prevent that the transport session is re-established, because every new transport session is a different 5 tuple, and then basically chooses anyway a different ECMP pass. Is that correct?
So it does mostly protect the established flow, like flow is already ongoing, like you said.
Yeah.
But they say at that time, another new flow start entering into this bad path or the black hole device. So we actually also changed the scene timeout retry. So even the scenes on timeout, they would try a different path that way. Yeah.
Right. But it's basically
Thomas, for the sake of time, yeah, please continue the discussion now with you offline. And thank you, Yusheng, for bringing this to us. It's really interesting.
All right. You hear me? Yeah, so my name is Wim Hendrik. So I did quite a bit of work on automating API software, and I'm going to share some of the experiences here based on my work, right? So thanks for the opportunity to allow me to present. So the motivation of the work started from the fact that we saw a lot of tools in automation being, let's say, developed from, basically they were trying to build declarative automation frameworks, right? And so we looked at like Terraform, Kubernetes is typically very famous in this space. And so I started to look at how could we use schemas that we are developing here in IETF, but or also somewhere else, and how could we leverage those schemas in order to actually leverage a more declarative operation in order to build automations, right? And so a disclaimer that I will make is that a lot of people know me from Kubernetes and Kubernetes-based principles, and I still believe that some of these principles are good, but most of the things that you see here and that I will present are completely decoupled from it, right? So in other words, you do not need, except for one, a Kubernetes cluster to deploy this, right? So now to set the stage, what I'm talking about when I'm talking about automation, right? So I think the stack that I typically see is you start from a high or potentially high level abstraction, and what that is for you, I don't really care, right? This is just an example. Then you have typically some business logic that gets to what I call a normalized model. So the normalized model is a device. So you go from service to device, right? And if you typically have multi-vendor, you actually want to normalize that because you actually have different implementations for that particular entity, right? And of course, a bunch of IETF models play in this space, but I try to be agnostic of that as much as I could to actually build flexibility, right? Now, what is important here, and I'm not going to drill into the data modeling as much in this presentation, more on the machinery to enable it, is what I feel is very important is the design and the data modeling that you do. For example, for me, what I did is like, when I built a VPN, I use this as an example, right? A service, whether you implement it with SRv6 or MPLS, or you want to migrate from the other, right? Or you want to start with IPv6 or a dual stack environment and you want to go to IPv6 only or something like that, for me is a parameter that lives somewhere, but is actually decoupled from all the rest of the abstractions, right? And what I wanted to achieve is like, okay, it changed my design, for example, from MPLS to SRv6, and all the rest of all the machinery automatically follows that, and all the resources that are related to that automation are automatically registered and cleaned up based on that single operation, right? So that's what I mean with declarative operation, and that's basically the framework that I will talk about. Now, and just to be clear, I just use this as a use case. You can actually model or build any automation or anything with that, because some of these things are being used in optics, some in IP, some in PON, some even use it for just cloud automation, right? Now, one of the lessons that I learned is that the schema, right? So and Yang is basically the schema language that we have in IETF, is a very important building block in my view, because we are a team of a few people that are actually working on it, and all of this is developed in open source, but you actually have to build the machinery to scale, right? And the basis of which what you start is typically an API that has a schema, right? And that schema actually defines the contract, if you will, from your API, right? So what are the parameters, what are your constraints, and what have you? And so one of the things that we focus quite a bit on is okay, if you have your schema, the validation rules that are associated with it, or the SDKs, the client side, or even the UI representation, right, should all be auto-generated and should just come out of a tool. You define the schema, and it actually, all the machinery and what I call the plumbing should not be, as from a developer point of view, being worked on, because actually the machinery should take care of that, right? And if you have that, I think then you actually accomplish a very nice, what I call developer experience, because what you then focus on is really the business logic, what you care about from with respect to the automation, right? And you get all the benefits of all the IDEs, lintings, of all the programming languages that have been developed outside of your ecosystem, out of the box, and you can leverage that, right? Now, to put that into perspective, so I just wanted to build a representation, right? Is today what you typically see is that when you take Yang, right, you typically get an implementation of a particular vendor, and you have the server that typically goes together with the Yang, right? The challenge is the client side, right? Because you actually need something to actually interact with that system, and you want that client side to be generated as well. And so the client is actually sometimes being consumed from a CLI point of view, from a UI, or from an application, right? And due to so what we do, what the situation that we have right now is that we have a bit of lack of tooling and with respect to Yang. And what people do today is they build templates, right? So people humanly craft templates to actually relate to the schema. And the challenge with that is you have to maintain them, and you have to, if the schema changes, you have to change the template, and then so that whole life cycle is completely decoupled. And what you see is that you spend a lot of time and effort maintaining that, right? So we try to avoid that if you have this machinery in place, right? Now, we see two use cases. So when I look to the initial picture, you have actually two use cases. So one of the use cases, if you look at the lower level, is actually we have various vendors of NOSes that have particular implementation, and they typically come with a vendor-specific model, right? And we wanted to actually have a vendor-agnostic tool that allows you to interact with them in a declarative way. So the first tool that we built is SDC. So the name is schema-driven. Actually, configuration is not really the right name, because in the meantime, we also do state, right? So we also do telemetry collection and stuff like that. But what this thing does is actually it allows you to interact with the system in a declarative way. We then act, as you can actually see, if you look to SDC, how I would explain it, it acts on behalf. So you load the schema, it pretends to be the platform, right? And it actually does all the validation on behalf of the device. And you, for example, you can do JSON in, XML out, or anything to anything. So, and it manages that in a declarative way. So it also does live drift detection. You can actually do what we call config blame. You can actually see this parameter of the configuration came from this intent. So you can do many things that actually makes the life of the operation teams very nice, because you actually can say this parameter in my configuration came from here, right? So that's the first thing that we built. And so what is also important, and I think it's interesting to look at this, and my plan is to write actually a draft with respect to onions. If you look to the framework, how it works, what we basically built is we support both Yang-based system as well as OpenAPI or JSON schema-based systems, right? And so you want to actually do that in conjunction, because sometimes you are interacting with APIs that are built on JSON schema. Sometimes you have Yang-based systems. So if you look at the system, how it works, at the end of the day, we have this meta header. And that meta header is actually the thing that actually connects the two, right? So for example, in SDC, what we did, we have a meta header, which is basically defined by the system, by the automation system that I'm talking about. And then you can actually map Yang schemas into it. You can map OpenAPI schemas in. So you are from a user level flexible on how you consume that and how you build your system for your particular use case, right? And that is a very powerful system, because it also allows you, which I'll talk about in a bit, to actually offload a bunch of operations to the server side that does things on behalf of the client, right? So in other words, for example, one of the big things that, and I'll see in how I do in time, is, for example, relationships. So this is not the right slide, but I'll talk about the concept. One of the things that we typically see in the whole this framework is like you build a schema, right? Now, for example, take an interface is related to a device. What you typically do in the specification is you say you have a parameter in the spec that relates that entity towards the other object, right? But the problem is that if you want to reuse that object or that schema in another context, you have to update the schema, which is not really good, right? So we build like relationship is actually in the meta header, and that allows us to be very flexible with respect to how you connect this data and how you can manage that data, right? So, and these are like, I think in the context of onions, important concept that probably is worth, so I will write a draft with respect to that environment in order to actually see whether we can reuse that thing in order to help that automation journey. Just quick, as the state of affairs, what we have is we have the validation side that is covered and that comes out of the box. So you load the schema, you do all the validation on behalf of the user. What we have seen is that we find issues in vendor implementations, which is interesting. And the way we detect them is because we can test the schema in conjunction with the data. And so one of the lessons learned is that because we actually validate according 100% to the Yang rules, that doesn't mean, so in a vendor implementation, it could be that you could offload some of that validation to the application side. So that doesn't mean that it doesn't work, but the implementation might not be 100% Yang compliant. But okay, that's a different conversation. Yes, yeah, correct. Important thing is, today we don't have the client side. We work with universities to actually get also SDK generation. So we actually hope by the end of the year to have some implementation. So we prioritize Python, Go, as you see here. If you're interested to join, please be welcome, because we wanted to actually build that whole ecosystem of tooling. Important, I'll do very quick because I'm running out of time, which I was expecting. What I talked about today is schema to device. But if you look to the bigger picture that I was showing in the beginning, is that there is a lot of things. So you actually have a client and a server. The more you can offload from a server in a generic way, the more simple you make the client, right? So for example, if you look to the system that we have Graph is a first-class citizen as an API. So GraphQL comes out of the box. You load the schema. It's not just REST or REST-conf. It's actually GraphQL as well. Because now you can basically some data or some objects you can actually relate to from client to parent to child, but also child to parent. So you can actually, with a single query, get the whole tree of all the data and how it's connected. So these are all the things that help simplify automation from my perspective. There is a bunch of others. My goal is to write a draft in Onions to actually talk about these, because I think automation as a concept deserves some of the support systems to actually help make it easier, and that's one of the things that we did. There is a tool, so Choreo is a tool that actually does the upper side of the thing, also open source. Interesting is it comes with the UI out of the box, right? So you load the schema, you get the UI. All the extensions that you see on the left-hand side are dynamically rendered for you. Full version control. So anything that you do, you can do a change control. So you can actually see if you change your automation, you can actually do a full diff of all the changes that you did. Look at that compared to a snapshot and stuff like that. So there is lots of machinery that is built, and I'm running out of time. So
yes, sorry, I'll have to stop there.
Which I was expecting.
Yeah, this is really interesting. So thank you, Wim, for sharing this. So please, again, reach out Wim to discuss with him if you want to more about this. And if you can.
Yeah, if you want to see a demo or you're interested, please reach out. All of this is open source, and if you look to the link, there is a Discord channel and a community that is actually working on this space as a whole.
And looking forward to read your Onions draft.
Okay, will do. Thanks.
Thank you, Wim. Arturo? You have to run.
They wanted to be, didn't want to be in the middle. So, okay.
So you have these minutes.
Okay. Well, my name is Arturo Servín, and I'm gonna present the interconnection API or the peering API. This is an API that we are working in the Grow working group, and it's about how we can automate public peering. So why emphasis in public peering is there are basically two types of peering, public and private. Public, normally you do it in an internet exchange point when you already have a physical connection to a switch, so you don't have to deal with any physical things. It's just the logical interconnection between two ASNs with a BGP. So you just need to agree in the BGP parameters that you want to do. So it's relatively simple. In a private peering connection, you need to start like, what is the speed? 10 gigs, 100 gigs, 400 gigs. Which type of optic you want? Also, who is going to pay the cross connection? This is normally a connection between routers that is a patch. It could be a transport connection. Ideally, you are in the same location, but then you need to do like a cross connection, pay to the facility provider to do that. So who is going to pay for that connection as well? You need to provide an LOA to say this is our demarcation paths, and then I have to, and I have authorization from this other network to use their MMR positions. So that is your LOA. Also, then you have to test the physical interconnection. You need to add more links because maybe you have a bundle. It gets messy. So basically, private peering is kind of a can of worms to automate. So we decided, let's go first with a public API, which is relatively simpler to do than private peering API. So what is the what was the peering before? Normally slow. I don't know if you were a few years ago. You will go every year to a peering conference, and then you will sit down in different tables, and then you will say, hey, I want to peer with you, how much capacity, etc., etc. Everything was coordinated by email. You will come back to your network. You will give your plans to your network engineers, and your network engineers, they will be like configuring the routers, and everything will be done. That was fine when you just have to add a few connections, but the internet has grown, the interfaces has grown, and also the number of interfaces has been growing. I think that in the last 3 days that I have been here in the IETF, I just reached a few terabits of capacity between some networks by email. It's still some of these part is still by email, but the other part is automated. So basically we have systems where you can go and say, hey, I want to peer with a Cloudflare. Something that I forgot to mention, the authors, we are Meta, Cloudflare, Amazon, and some other companies. And we used to have, or we have this kind of portals or systems where you can go and request peering with this network. So this is fine. Basically, what it does in the back is goes and configure a router, check some parameters, maybe checks that you are the owner of that ASN somehow, and then the peering is done. So this is fine, but what happened when Google wants to peer with a Cloudflare or with Meta? It's like, well, you go to my system, no, you go to mine. So it's like that part is like, even though that part of that provision is automated, there is a very manual part still there that we want to get rid. So my ideal, it will be like go to a Gemini or ChatGPT or your LLM of a preference and say, hey, I want to add a peering interconnection with Cloudflare in a DECX in Frankfurt, one in AM6 in Amsterdam, and another with Spanx in Madrid. And Gemini will do that, the magic, and then we'll go to the API that we are proposing and then send the request to the system that is in Cloudflare, and they will receive it and they will do the configuration, and I don't have to do any manual tickets. That some part of that is automated, but some part is still manual. So that will be like the future. So that is basically what we want to do with this API, is like to have this machine-to-machine configuration. The goal is to reduce the human time that we have to spend in peering. Today will be like a public peering. Public peering regularly is the majority of peers that a network will have. in volume is not the same because normally your volume is more in private peering, but the number of peers are more in public peering. So it's the more work that you have because you have to add more peers there. So we want to also reduce that human time spending on that. Also, like, well, improving network latency. This is like the commercial that we have the peering people. Like, yeah, let's do the internet faster without peering. Requirements, we have to have some security. To be honest, when we start this, we were like, hey, we are using PeeringDB. It's like all the information is there. They check somehow, like they do a good job. It's not perfect, but they do a good job checking that you are the owner of that ASN and you can talk in behalf of the peering of that ASN. So we said, well, let's use PeeringDB. They have the database and they have the authentication. When we came to the IETF, well, you know, it's like a third party, so we have to have something like more neutral. So since then, we have been thinking how we solve that. One of the solutions is that we are going to use like regular peering databases. There are databases that are maintained, for example, for Euro IX or Global IX or the IXs. So you can use that. And also you can use OAuth authentication with PeeringDB if you want. But also the feedback is, let's start using RPKI. There is not exactly say how we are going to use RPKI. So one of the things that we decided is, okay, let's use RPKI with OAuth, but let's separate it in another draft. So one of our co-authors is going to do that. So they are going to like work on that and say, okay, this is the way that you have to do it. What we are doing in the draft is saying, hey, you can use OAuth, maybe with PeeringDB or RPKI, and if you are using RPKI, use this part. So basically, like that is the status. This is kind of the workflow of a peering request. These three first are basically like human done. It's like, hey, I want to peer with you. Yes, let's peer. Can we peer in this location? That's okay. And the other ones is all that the API can do, like deciding, like, okay, checking, like deciding that you can do the session, where you're going to do the session, the IP addresses, etc., etc. For the private peering, this will be much more complicated. We start already working in the draft. Is like super like new, so we haven't even submitted a proposal yet. But we are working in this precisely in this flow that we will have for private peering, and this is the flow for a regular public peering that is much simpler than the other one. The overview of the API. So basically, we request new connections. You can list the connections that you already have with another peering partner. You can delete some of the connections, and the authentication, as I said, is done with OAuth and RPKI. The flow of the API, basically you do a request, you add the session, then it's approved, then it can be a partial approve of that session, maybe like you will, and I think that this is mostly thinking by the private API, where private peering, when there are some changes that you want to do in public peering, maybe the prefix, the BGP prefix list that you are going to have, like the number of prefixes that you are going to accept is part of that partial approval. You can reject one. There are networks that don't like to peer in IXs for some reason. I can tell you why Google doesn't want to. Monitoring, and then finally completion. Authentication, as I said, is done by OAuth or with with PeeringDB, for example, or with RPKI. That is going to be the preferred recommended method to do. This is some of the data types that we are using: peering location, session status, etc., etc. Discovery. So far, there is no API discovery, so it has to be manual. It's something that we ask in the Grow working group. Is like, do we have to have something more complicated, or this is okay? So it's something of the feedback that we are looking with the next versions. This is part of the endpoints, sessions ID, locations, and in the future for private peering that it doesn't exist yet. And as I said, what is the future? The future, it will, well, finish this draft and then use some part of that learnings and that API specification to do the more complicated that is the PNI, that it will require a little bit more of work and probably pre-work between entities to negotiate some of the parameters that are going to be there unless it's going to be very complicated. So this is something that we need to do. And if you have some questions, remember that I'm a peering guy, so I normally know about more peering. The other part of the specification has done by my colleagues that are software engineers and expert in security. So if you are asking about security and APIs, I'm probably not your person. If you are something about peering, yes, I can answer that. Question? Okay.
I don't see anyone in the queue, so thank you.
Thank you very much.
Hello, everyone. My name is Xie Zhongfeng. I'm from Challenge Telecom. It's my honor to give a presentation about the Challenge Telecom's API approach today. Thank you for the invitation of the AD. And first, I give a brief introduction of my company, Challenge Telecom. Challenge Telecom is one of the 3 major operators in China. Right now, we have more than 100 million mobile users and more than 100 million wireline users. Yeah, let's start with the background. China Telecom's API practice is driven by cloud network convergence. Maybe this is special in China, and which means that cloud has been an important part of the digital infrastructure. So in order to manage this evolution, we have developed a unified cloud network operation system, which has integrated network, cloud, security, data, AI capability in this system. So the system can intelligently orchestrate these capabilities. In addition, this system can abstract the network cloud capabilities and expose them to the applications, including internal applications and outer external applications via the layered model and open API. So our network operation follows TMF's layered PSR layered model. There are 3 major components in this model. CFS, which means customer-facing service, which provides service that can be experienced by customer. And the second is RFS, resource-facing service, and which provides some major capabilities. And the next one is resource, such as network equipment, device ports, CRUD, number links, VPC, etc. So this layer model decouples the capabilities and standard them, and share the difference of vendors, so operators can easily develop new applications based on the predefined components. Right now, we have developed more than 2,000 capabilities and more than 300 products, enable agile delivery, service delivery. And with this kind of open system, we have developed connectivity capabilities, computing capabilities, data capabilities, and operation capability with over 450 operation commercial capability, and a total of which have achieved more than 70 billion API calls right now. So let me take a cloud-oriented VPN product example to illustrate the API. This product means that we provide a high-speed, low-latency, stable, and secured data collection from the customer's data centers to cloud VPC. So it actually provides users with the internet access, cloud access, multi-site network, multi-networks. And so we fully leverage the capabilities of network, such as access and backbone networks involving 7 domains, such as PON, metro area, IP RAN, S10, etc., the same 2 backbones. So we can see there's a lot of capability and even the resource. So take this VPN product example, we have 3 CFS, fixed access NAT, and the fixed internet access, cloud to NAT CFS. In addition, we also have 70 FS, so there are 20 objects totally. We also have 288 APIs for production collection, for modification and deletion. And with these APIs, the capability reuse ratio can reach to 74%. So this shows API some of the of these products, just on a cloud-oriented VPN product, such as authorization APIs, resource management APIs, and the data collection APIs. Of course, it's only a subset of all the APIs. So how does it work? We have seen that CFS provides user experience service. So this API process shows how to deliver service with these capabilities. It is use some kind of network topology. The topology can implement the mapping from CFS to RFS. So it may have multiple topologies in this case. So let's take the fixed XNet service creation example. Firstly, we give the resource allocation, which means allocate a VPN number, IP address, secret ID to this service, and then at the service orchestration step, we realize the mapping from CFS to RFS. Here we can see there are two RFS. The first is the IP run PW access RFS, and the second one is IP run CN2 RFS. There are two steps, so we need to implement the two API calls here. The last step is testing to ensure that the service running normally. So this is about API process RFS, and it is similar to the CFS, but they have different content. For the resource configuration, meaning for some device related resource configuration, then we use a network controller to configure the device. For example, config creation, configure device U and device B. The last step is on-site operation. So this is about the RFS. Yeah, so regarding the network controller, actually we use some we have used a self-developed network controller for the device configuration, and we have known that there are lots of several vendors there are difference in their interface. So we developed a unified YANG model, which is called City YANG for this device configuration. This is YANG-based, a RESTconf-based YANG model. It is more suitable for complex network configurations and close data form of device, shield vendor difference, and improve efficiency of information understanding processing. So we call it, so it's called the Open API of China Telecom. The Open API interface actually provides three types of interface, and the service level interface, and the modular level interface, and the field level interface. For this mapping from the northbound API to the southbound vendor YANG, we have developed which is called Fast YANG tool, which can mapping this from the northbound unified API to the southbound vendor YANG. So here I give an example about the mappings. This, okay, no problem. So this is is used to configure device logic interface and bind to a specific VPN services. So the next slide shows the northbound YANG model-based city YANG. So with this kind of mapping, it can be transformed to to vendor-specific YANG models to issue the configurations or to device or the performance data from the device. This is our team. We have more than 500 members, an R&D team for overall planning, system designing, coding, development, testing, development, standardization. We also join TMF, ONAP, JSMA, ITUT, etc. So we use a lot of YANG models in our system. Actually, we encounter a lot of challenges because we feel that the standardization IETF lags behind of the industry. And so vendors often develop private YANG to meet the rapid development of operators. The second challenge is that IETF models focus on basic network objects, but lack complete function definition operator specific scenario, so resulting in functional deficiency. I think this is my second experience. The last one is that private extension by vendors. This is also very serious. And last one is data consider risk. So I think all these issues can be solved by Onions in the future. That's it.
Thank you very much for
completing on time.
Thank you. Thank you. So the next presentation will be ISCO giving us to, I would say, presenting us another, I would say, topic and field. An exercise I provided to ISCO is to see some of the requirements for the telemetry and see how the native function provided by co-op and company will meet in this requirement. So thank you, ISCO, for trying to do this exercise.
Okay, thanks for the invite. So this is a quick introduction presentation on co-op. So I've been active in the co-op working group for quite some time. So I also helped with the review of the original co-op protocol. So here's a quick picture that basically shows co-op deployed in a network system roughly and pointing to the various requirements that were applied in the design of co-op. So I think after the meeting, there's also some time in the break. We can discuss further on co-op because the time here is, I think, limited. So the background here is basically, looking at various use cases where lightweight UDP protocol may be needed. So co-op is such a protocol. It could be network telemetry. So this is what it today focus on for this presentation. There's also other uses for co-op, for example, the management of low bitrate networks using 802.15.4, 6-LoWPAN mesh networks. So this is more my background where I work on. Also considered now in the ANIMA working group for management of control planes for memory constrained routers. So again, the question is to co-op or not to co-op. And cellular IoT device fleet management is also something where basically RESTful operations are desired, but on the other hand, bits are quite expensive depending on the subscriptions used for IoT devices. So there also people turn to co-op to save data. So there's often this choice like, okay, what do you do? Use an existing off-the-shelf protocol, accept some overhead of the protocol, or design something yourself with UDP. And lightweight M2M and thread mesh networking are examples of standard that did adopt co-op for some particular purposes. So let's go quickly over the features. What can co-op offer? So it has these port numbers assigned, which is in some cases also nice because you don't need to try to get a port yourself. It has compact encoding for various things. It supports multicast, so unlike HTTP. So the basis for co-op design was HTTP. This extends it also. It has selectable message reliability, so you can per message you can choose do I send this reliably or unreliably. Reliability means retransmissions are possible. And there's optional security layers. So at the moment we have DTLS or TLS or OSCORE defined. And OSCORE is basically the latest addition for security. It's specifically designed for IoT, so it minimizes size, memory usage, and round trips as well. I found one standard called KNX IoT that is relatively new for building IoT devices that uses this. So another feature of co-op is that it's built to be modular and extendable. It's more like a protocol toolkit, so to say. So you can grab features from various follow-up RFCs and extend the protocol this way. This covers many things like options can be added, content formats, also parameters can be varied of the protocol. So you can use a different parameter set for your use case. There's things like the RESTful methods, just like with HTTP, that can be extended as well. We have the resources, etc., etc. So there's various features there. The basis for co-op was basically to provide a RESTful communication paradigm, explained on the next slide, and to have multiple transports possible. So this includes UDP, TCP, but also things like SMS or very specific LP1 protocols. So it doesn't have to go over IP, but also other carriers are possible. I think there is still some work on this area. So the picture here kind of shows the overall idea of co-op. So it's a single layer protocol, but it has like 2 layers inside. So there is this reliability and framing layer. And there's on top of that, there's the REST layer added. So it's kind of a dual split layer design, and things were still a little bit integrated to basically make it efficient. So they're not completely separated layers, but interact with each other. So some cross-layer design optimizations have been made there. So you can think of it as a lightweight alternative to HTTP, do the same kind of operations, basically. In the middle, some of the transports are mentioned, which I also mentioned before, like SMS or Bluetooth even. Yeah, various types, other types of networks. Now move to the next topic, which is some examples. So these are very simple. So we have basically on the top a device that's a controller that wants to get the status of an alarm node. So it performs a get operation to a resource called /status, and that gets an OK code back, code 2.05, with some payload, in this case indicating the status of the node. Second example is a phone that wants to open a smart lock, performs a put operation to change the state of a resource. So it basically puts a value 2 in there, and then the lock could, for example, open. So these get and put are the REST methods used here, and there are also more of these methods. And the picture here shows the co-op header. So this is roughly the minimal amount of bytes you need in a message. So that's minimal 4 bytes. And there's a couple of optional things there. So you can optionally include a token, co-op options, or payload. It's not present in every message, these items, so you can have pretty short messages as well. But the typical size of a useful co-op message will be a bit more. There's also Wireshark capture there shown on the figure. So that's basically the things I look at more in my daily job. So when co-op is used in the thread protocol, you see these kind of things. Well, one example of using co-op RESTful is so-called CoreConf. This is being developed by the core working group. So it's basically a lightweight co-op versions of the existing RESTconf, so like a port of that. And this includes things like subscriptions to basically notifications, get notified about changes in a target device. And that uses the co-op observe functionality. So this kind of replicates most of the features of RESTconf that would be suitable for constrained devices. So relatively simple IoT devices, for example, that have low memory and small code size. It tries to be compact on the wire as well. So we have, instead of more lengthy JSON or XML encodings, it uses CBOR here. And in that mapping, basically all things that are normally string names in these Yang data definitions are basically substituted by numeric IDs, so to make it more compact to transport. And it can be kind of automatically translated basically to and from a human readable JSON representation, for example. Now, this was RESTful use of co-op. What about RESTless use? So if you don't need all these REST features, can you use co-op and make it more efficient, more compact even in this way? Well, this is possible. One example is listed here. So you could have a sender being a co-op client and a receiver, a server elsewhere is the co-op server. The client can send a very compact, short message, for example, a post request, posting to a small resource /C. So that's kept very short, because the resource name is encoded on the wire. So we use only 1 byte there for the C. And for the rest of the payload, you can have any binary data that you want. So that's a way to transport data. And if you want this to be without the normal response that is usually done in RESTful protocols, then you can also opt to suppress the response. The server could decide that, for example, if it sees like, hey, I got a request in and this does not need any reliability. So it's like a fire and forget type of message. Basically, the server can decide, okay, I'll just drop the response, because the sender is not going to retransmit anyway. It's not going to do anything with that. I don't have anything useful to respond, so I can just drop it. So you get a kind of one-way communication. Yeah, there are some discussions going on, I think right now also in the core working group, about the use of the resource names. So the /C here, for example, is a pretty short resource. There is also an IETF RFC that says any IETF specifications must not hard code these resource paths. So the idea of, just like HTTP and co-op, it's shared resources. The operators of a system or the system implementers are supposed to pick these resources. And it's not something that a protocol document should hard code, because yeah, before you know it, all the resources with short names have been taken, and etc. So that's an ongoing discussion what to do in that case. So you still want the efficiency of short resource names. So there are some solutions to that as well. For example, configuration in some way, yeah? Like application-specific configuration. Now, if we look at network telemetry, that's the final part. So looking how can co-op be applied there. This kind of summarizes a few requirements. So I got some very good input from Thomas Graaf here. Thanks for that. That's basically what do we need for network telemetry applications. So that includes, for example, sending with Anycast some telemetry updates to a set of central servers, and the sender doesn't know where these servers are located. So it's Anycast based. It just goes to the nearest collection point in the network. And yeah, some requirements there are listed here. So the message size overhead needs to be minimal. So we want not to eat away much of the network capacity there. Message length could vary. There could be a segmentation of one message over multiple packets. There's no ability to store anything in the network itself. And yeah, so it's kind of a summary of the requirements. And this looks possible, I think, with co-op. It even has a blockwise feature, basically, that allows to split a larger message into smaller chunks for efficient delivery. And finally, yeah, would there be any benefits of using co-op here over the new UDP protocol if you can design a new UDP protocol from scratch to do this telemetry reporting? So that's a good question. I don't have a definitive answer here. Could say it depends. It would be good to start a discussion, I think, and maybe the core working group can also help there. Some things to look at for sure are here, like, okay, do we need, for example, security or the option to secure the messages in the future? And if the answer is yes, then it might be useful to consider that, because we do have this lightweight security option. And other thing is that there are blockwise transfer methods available. So this could also be useful if you consider larger packets and you need a way to chop a larger message into parts. And number 3 is like the overhead, of course. Do we accept there is some overhead? There's always some number of bytes, and a dedicated protocol can always be more efficient because you can just remove that header, of course. And number 4 is the RESTful paradigm. So co-op was really built for that. And sometimes you see applications that don't need REST still want to use co-op, and then maybe the question is, well, is that useful? You don't get the full benefits of co-op in that case. So it might even hinder in your application. So these are good things to consider. And I think there's 1 minute for some questions. So let's do that. Thank you. Great, Torles.
Yeah, Torles Eckert.
Just keep it short, Torles, so that we can...
Yeah, maybe the question that more of us should ask themselves is, when we have a new protocol to design, that could use HTTP or co-op, right? Why would we still want to go for HTTP unless we know a crazy feature or so? And I think that's something we should reflect on. But I'm not sure what your opinion is.
Yeah, that's good. My opinion is, I first would need to look at also HTTP2 and HTTP3, I think, regarding efficiency, because that's something also to compare co-op against. I know it's for sure more efficient than HTTP1. So it's a good choice for that, but yeah.
Hi.
Scott Mansfield, Scott Mansfield Erickson. This is interesting work to me. I also do some work in the IEEE, and it might be worth to consider sharing this information with the IEEE. Their aerospace profiles, for instance, are trying to do this, and they don't like Yang because it's too heavyweight, but co-op would be a good thing for them to use, and this shows some maturity. So thank you.
Okay, yeah, that's maybe for the core conf protocol, right? It gets the benefits of the Yang models, but without the long strings.
No, you know, Hank, you're not coming. That just as a matter of making a little commercial on this. When you talk about security, we are working, and we are going to talk about another draft in the OPSAREA, in which we're using for providing integrity and origin of the telemetry messages. And well, we're using CBOR for the signatures. It's about signing in a concise way.
Okay.
Using CBOR, I think it would be applicable here if you are, well, if you're thinking about using DTLS or whatever for the transport, is another story, but that would provide security without making the whole thing very, very complicated. Just as a note.
I think that's a bit similar to OSCORE in a way. Indeed, yeah, it's much lighter than the TLS or TLS. Yeah. Okay, thanks.
Thank you. Let's go.
All right, thank you. I already used 1 minute of my time, so I will make sure to make that up. I'm Scott Mansfield. I am affiliated with Ericsson. I just was asked to provide a few slides. There's like 26, but I'm not going to go over all of those. I provided them for background. And so just to give you a idea of what the liaison process is, and if you have any questions, you can always contact me. My email address is firstname.lastname@ericsson.com. Pretty easy to remember. So this is set up to be a much longer presentation. So if you download it, you can use this to get to the different places in the presentation. What I'm going to start with is the executive summary. And then if you want way more detail than you need, you can continue looking at the slides. So why does all of this stuff matter? Why this matters is that we have organizations, the IETF and the ITUT, that are all working in ostensibly the same space, but the ITUT is a treaty organization. It's a standardization organization that works as part of the UN system, and they are contribution driven, kind of like IETF. They have industry engagement, kind of like the IETF. It's not a research organization, kind of like the IETF. But the difference is that the ITU looks at problems from the top down and is very government and member state focused. So they don't treat the individual the same way that the individual is treated in the IETF. And that leads to some differences in the way you have to communicate when you're communicating between the organizations. Top-down messaging is important. There's also, it's a very political organization. There's technical monitoring and engagement that's needed. So I asked Copilot to tell me what this looks like, and it did a pretty good job of coming up. If you look at ITU standardization, it goes top down, and if you look at IETF, it goes bottom up. And so where I live, where the liaison program, the communication between IETF and ITUT lives, is in that area where we get something from the ITU that says, we're doing AI. Okay, where do I send that out of the 120 working groups there are in the IETF, right? And so I have to look at what they're doing, what they're thinking, what we're doing, what we're thinking, and figure out some way to make a coherent response going back. So that's kind of the job here that we have to look at. And so for a summarization, I just said, you know, what are some of the hot topics? The ITUT is working on all of the, if you want to win buzzword bingo, go to an ITUT meeting, you will win. Because they have study groups that are just well, we're going to do blockchain with for control protocols using AI, ML, and quantum. Bingo. So the important thing to take away from this, however, is that when we share communications from the IETF's perspective to the ITU or from the ITU back to the IETF, if the IETF receives a liaison and doesn't respond, silence does not mean consent.
Can you just repeat it again, Scott?
Yes, we should all just stand and say it together. Silence is not consent. Okay, so one of the things that, yeah, we have someone standing who's going to help me say it. No, anyway, there is a set of liaison templates that I've created that's on the IAB's GitHub that shows what I do when I receive a liaison from the ITUT. There are canned responses that we send back that basically say, okay, we got it, we're going through our process, silence is not consent. Okay, just so that, because we had some trouble with this in the past. So I'm running out of time, so I just will say, if you have questions about the liaison process, I'm the IETF's liaison coordinator to the ITU. There are two other individuals, Deborah Brungard from AT&T and Jim Reed from RTFM. They help me out. There's a Rudiger Grieb that also helps out, because there's so much going on in the ITU. I'm glad to have people that also go to different working groups in the ITU and they can tell me what's going on. There's a study group 13 meeting going on right now. That's their future networking group. We're going to receive probably 15 liaisons next week. So it's going to be some fun stuff. But just to show you, I'd show the structure of the ITU, who the elected officials are, where the organization goes, what the study groups are and what they do. These are new. There's been some consolidations, and a new one added for multimedia content delivery, and cable television was one that they took two working groups and made one working group out of it. There are, just to show the people that attend and the participation from different groups. There's the WTSA is their big organizational group meeting that happens every 4 years, and it talks about the resolutions that they make. They have a cybersecurity one, they have non-terrestrial network stuff, so you can see the kind of stuff they're working on. What their mandates are for each of the study groups, you can look through that if you care. And then when their next meetings are, like I said, the meeting's going on right now. We have Arnaud Tadai is a guy that comes to the IETF. He's the chair of Study Group 17. Their meeting happened a couple months ago, so they'll have another one at the beginning of 2026. We also have Glenn Parsons from Ericsson as the Study Group 15 chair. He's here this week if you want to talk about the work in Study Group 15, which is transport, access, and home. This is our coordination method. We do various things for coordination. I am also the ITU's liaison coordinator back to the IETF. So I try to do as much training as possible for the new people that come in. I fail sometimes or don't get it done in time. So it's always a work in progress. And like, if anybody else is interested in this stuff and wants to help out, this is the kind of thing that we're looking for. These are the types of things that we've been coordinating on. There's this Yang at scale issue. There's some time synchronization stuff. If you want details, you can come talk to me. And then the liaisons, and one thing I will say before I close here is that new work sharing in the ITUT, they are not allowed to share the new work that they are doing until they approve the starting of that work. And by the time the work has been started, it's too late to change anything about what they're going to be working on. And that's what causes some of the friction between the two organizations. It's gotten better, but it's still, that's still something that happens. Oh yeah, it's a typo. It's not 118 anymore. I used these slides before. Anyway, silence is not consent. We say it again. One thing that we try to do, we have tried to do in the IETF, in the ITUT, is to ensure that they do a gap analysis and to make sure that the work is being done in the industry recognized center of competence. The IETF is the industry recognized center of competence for IP. early identification of overlap. And so, you can just see all this stuff. So I'll let you read these. So I think that was it. I think this is the last. It won't go no more. So I guess that's it.
So, thank you. Thank you very much.
So that's it.
Mike?
I'll be quick. Mike Blanche. First of all, thanks, Scott, for all the work you do here. I know there's a lot of stuff that comes in from the ITU and it all needs looking at. So I'm another person that goes to the ITU as well as to the IETF. Silence is not consent. I know you've said it many, many times, and it's true. In ITU world, if there's no input back from things that are sent out in terms of liaison statements, it's very hard to push that point.
Yeah, that's why I do it when I'm there, right? You have to do it.
Is there what things can we do to try and reduce the silence, or at least the period of silence, so that we can respond to these things better?
Well, that's why we created the set of templates. I suggested you go look at the IAB GitHub, look at those, make sure you're comfortable with the wording, because that's our main way right now, is to say, look, we received it, we're going through our process. If we don't finish our process, we don't have anything to say about it. So, yeah. Okay. Thank you.
Thank you very much, Scott. And thank you all for attending the OPSAREA. Yes, please. Thank you very much.